Hi out there, it's me, Steve. I live in this house with my puppy Blue. Come on in. Oh no, I can't find my dog Blue. Have you seen him?
No!
You haven't? Let's play Blue's Clues to find out where he is. Look, it's Magenta jumping down the road. I wonder if he knows where Blue is. Looks like for every jump, he's jumping an additional -1 to the power of n minus 1 times 2n over 4n minus 3 meters. I wonder if he'll ever stop. Let's ask my brother for some help. Come on, Joe.
Hi, I'm Joe, and this is my handy-dandy notebook. Okay, so we know that Magenta's movement is equivalent to the series from n equals 1 to infinity of -1 to the n minus 1 times 2n over 4n minus 3. So, what kind of a series is this?
An alternating series!
That's right, it's an alternating series. So we want to determine whether or not this series converges, which means that Magenta will eventually stop bouncing and come to a stop, or diverges, which means she will jump forever for the rest of her life. So, in order to determine whether it converges or diverges, we need to know two things. What are these two things?
A sub n is decreasing! And limit as n goes to infinity of a sub n equals 0!
That's right. We need to know whether a sub n, which is this part right here, decreases. And we need to know if the limit as n goes to infinity of a sub n equals 0. Okay, so to determine whether or not a sub n is decreasing, we look at the ratio a sub n plus 1 over a sub n. And this equals 2n plus 2 over 4n plus 1 times the reciprocal of a sub n, 4n minus 3 over 2n. This equals 8n squared plus 2n minus 6 over 8n squared plus 2n. Now, if this ratio is always less than 1, then we know a sub n is decreasing, and if it's greater than 1, we know a sub n is not decreasing. We look at this, and whatever n we plug in here, this -6 on the top is going to make it so that this is always less than 1. So the first step is good. For the second step, we need to determine if the limit as n goes to infinity of a sub n equals 0. So first, we set up our limit. Limit as n goes to infinity of 2n over 4n minus 3. Now, what do we do here?
Force factor!
That's right, we force factor. So, we set this up. We have limit as n goes to infinity of 2n over n over 4n over n minus 3 over n. We know this is going to go to 0, this cancels, and this cancels. So our limit is equal to 2/4 equals 1/2. Unfortunately, 1/2 does not equal 0. Therefore, we know Magenta will never stop bouncing, so we cannot get her help.
Thanks for your help, Joe. I wonder where Blue could be. Do you see any clues? Oh look, it's a clue. It's Blue's paw print on a rug. That rug is modeled by the equation r is equal to 1 plus 1/2 sine theta. I think we need some calculus to figure out if Blue could be under that rug. Joe, we need your help!
Okay, so now we want to check if Blue is hiding under the rug. We know that the rug can be modeled by the equation r equals 1 plus 1/2 sine theta. And we know that Blue has a surface area of 4.5 square feet. So, in order to determine whether or not Blue could possibly be under the rug, we need to see if the area of the rug is greater than Blue, so she could hide. So in order to determine the area of the rug, we set up the integral 1/2 times the integral from 0 to 2 pi of 1 plus 1/2 sine theta squared d theta. Now, using our handy-dandy calculator, we see that this integral is equal to 3.534. Unfortunately, this number is less than the surface area of Blue, so we know that Blue is not hiding under the rug.
Yes. Well, I've done everything I can to find Blue. I just don't know what to do now. Wait, I have an idea. I'll ask Salt and Pepper. Let's go! Hello, Salt and Pepper.
Hello, Steve. Bonjour, Steve. Do you know why we French make our omelets with one egg? Because one egg is enough. What can we help you with, Steve?
Well, Pepper, I've been looking around for my lost puppy Blue. I've solved some clues using some calculus, but I still haven't found him. Do you have an idea where he is?
Oh, I think something terrible has occurred. I think the answers you are looking for are on the TV.
Thanks for the help, Salt. Let's go look, guys.
We know that Blue will die when the volume of the hot oil in the cone is equal to 250 cubic meters. We know the radius of the cone is equal to 2/3 of the height of the cone, and we know the change in height with respect to time is equal to 0.2 meters a minute when the height of hot oil in the cone is 3 meters. So, given that the volume is added to the cone at a constant rate, if we can find the change in volume with respect to time, then we can find how much volume there is in the cone now compared to 250 meters and find how much time it will take for all of the hot oil to be added to the cone, and therefore how much time we have until Blue dies. So, the first step is to find the change in volume with respect to time of the hot oil in the cone. So, we know that the volume is equal to 1/3 pi r squared h. We also know that r is equal to 2/3 h, so we can rewrite this as 1/3 pi 2/3 h squared times h. And this is equal to 4/27 pi h cubed. So, now we find dv dt. And this is equal to 4/27 pi, because this is the constant, times 3h squared dh dt. So now we plug in what we have, which is height is equal to 3 meters, and dh dt is equal to 0.2 meters a minute. So we find that dv dt is equal to 4/27 pi 3 meters squared times 0.2 meters a minute. And what we get is that dv dt is equal to 2.513 meters cubed per minute. Next, we need to find the current volume of the cone. So for this, we just plug in our values for r and h. So our volume at the time where the height is equal to 3 minutes equals 1/3 pi 2 meters, since radius is 2/3 height, squared times 3 meters. And this is equal to 12.5664 meters cubed. So now we take the difference of how long of the volume at which Blue will die and our current volume, and we get that the remaining volume to be filled is equal to 237.434 meters cubed, divided by dv dt equals 94.4823 minutes.